The shift, to not put a too fine a point on it, is curation before annotation. So the traditional route is you might label everything, perform a whole bunch of annotation, then train on the model, and then QA kind of might be an afterthought in the sense that it's difficult to kind of reverse the loop and go back into annotation when you don't actually know what in the data is causing your model to fail. So there's a little bit of hoping for the best. And that's what this bottom left graphic is showing, right? You have a pool of unlabeled data, you label everything, you train the model, and then, maybe more of your effort in this case would be on the model architecture side because that's what you have control over. What we want to take is more of a feedback-driven approach. We can use curation techniques like embeddings and then what we'll call Z-score or core set zero-shot core set selection to find the highest value samples that are worth annotating and then train the model based off those samples. The idea here is that we are using very objective criteria to determine what data is likely to have the most generalizable model on the front end. And then we evaluate and find where is our model failing. And then from there, repeat the loop, right? If we can identify the parts of the embedding space that our model is not performing well on, we can redo the flow, identify additional samples, and either qualitatively by just examining the embedding space visually, or by performing methods like core set selection that we'll talk about, and then choose additional high-value labels for reannotation. And the idea is we're having a very metrics-driven approach for continuous model improvement.